so we can get started. Very good. We're going live, and we are live for live stream number 93. And we've got an action-packed week this week with several other things that are going on. So I'm really quickly going to drop the link, all right, so you folks can check out all the other things we got going on the Data on Kubernetes community. Obviously, like I said, there's a bunch of stuff going on this week. Most specifically, on Wednesday, we have the first DoK Students Day. We'll have over 25 different speakers that are all students. We'll have 30 speakers in total, around 25 that are students. Many of them will be giving talks for the first time, but all the talks are related to Data on Kubernetes topics. And speaking of Data on Kubernetes, I put the link earlier for Ionir, but our guest today, Barak Nissim, works in Ionir, and if you go to their website, they couldn't make it clear that they are truly focused on running data on Kubernetes. Barak, welcome. Barak joins us today from Tel Aviv, Israel. Welcome to the Data on Kubernetes community. Very happy to have you here with us. Can you just give us a little bit of background about yourself and about how you started working in Ionir and what Ionir is doing?
Perfect. Okay, so thank you very much for having me around. It's been a pleasure even before going live, so it's a very good discussion that we have. So my name is Barak. I've been in IT for almost 20 years now, although I might look a bit young, but started my way around, services companies, doing different projects for many flavors of customers, if it's high tech, if it's governmental, and so on. And my background is mostly around VMware. It was 10, 15 years ago. That was whatever was around VMware. And yeah, I've been in VMware almost 9 years. And I've moved to Ionir just the start of this year, so January 2021. And we surf the Kubernetes wave, and we see a lot of customers that have shifted the way of, let's say, doing applications from virtualized environments toward a more containerized environment, and even more than that. And we see a big trend right now also of customers that are already running their, let's call it ephemeral workloads on Kubernetes, but we see more and more customers, very hungry and very interested in running data on Kubernetes. And this is exactly why we're here, and this is exactly our solution. So we are, I'll do a quick couple of slides in my session, but in general, we are persistent storage or software-defined storage provider on top of Kubernetes. Of course, we are CSI compliant, and we run on top of the Kubernetes platform, and we are everything cloud native. So our application or our data services are all broken down to microservices. We are elastic, we are agile, we can run on-prem and on the cloud. So we kept the cloud native theme going from end to end in means of what we do. So we are just another cloud native application. The only difference is that we are providing storage to other applications that are running on these clusters, and be any data on Kubernetes flavors that you have, if it's databases, observability tools, whatever, analytics, machine learning. So everything is our play, and it's our let's say bread and butter. And that's about it. I think it's a good intro. We are based in Tel Aviv. The R&D offices are in Tel Aviv. And we have a big branch of sales, marketing, and so on in the US, in New York specifically. So if you're in the area, drop by and say hi. And that's about it.
No, that's a great intro. And I think it's also nice to see, particularly in this case, a cloud native, Kubernetes native approach. Whereas other, firms out there have kind of had to suffer through this transition of how do I break out of the old, move into the new. Ionir, it sounds from the word go, has been very, very focused in this direction, which is nice to see, particularly in our data on Kubernetes space. That being said, Barak, if you want to share your screen, we can jump right into it. Yeah. Just a reminder to folks in the audience, feel free to keep those questions coming. We'll get them answered accordingly as the presentation proceeds.
Let me just share my.
Yep.
I think I need to share this screen or that screen. I'm not sure.
No worries. It's all good. It's all good.
If you see the right screen or not, let me just verify.
Okay.
I do.
Yep, got it. Perfect.
Do you see the presenter? Do you see the?
Oh yeah, we see it in presentation mode. Yeah, now we see it. Perfect. Now it's great. Awesome.
Perfect. Okay, so So again, thank you very much for having me. So the topic that I chose for today is specifically around, I'll call it DevOps environment or CI/CD environments. It means of running dev and tests in a very Kubernetes aware mode. And we know a lot of customers are still running that on virtualized environment or using other services for that, but we see the power of Kubernetes also for these kind of environments. And of course, DevOps have so many different flavors of definitions. I'm not here to teach you about DevOps or what is DevOps. I think everyone has his own flavor, but in essence, it's moving, application faster, connecting between development and operations, making it easy for developers to build and test and release their application. And of course, doing that in a very, solid manner. So the less bugs, the more agile they can do it, iterative mode and so on and so on. There's a lot of, buzzwords around this DevOps space. But in essence, when we talk about DevOps and how we look at, where data plays part as in this kind of pipelines, we see it in few different places. I picked the top 5 of them, which we're also going to talk a bit deeper as we go forward. I'll just touch them very quickly. So it means of where you want to scale your pipeline means of artifacts created, or the development environment, or where you do staging for your code and so on. That is part of the data that is running in your Kubernetes cluster. So other flavors, each step or each stage is kind of ephemeral. It's running its own thing, and it's pushing that outside of the Kubernetes space. And we would like to keep it inside of the Kubernetes space because we believe that data is as an integral component of the infrastructure, like security and like monitoring and the rest of the let's call it IT stack. So there's no need to send or remove the data from your Kubernetes cluster to offload the data to other, let's say, components in your infrastructure. You can keep it inside of your Kubernetes cluster, and that will give you great scaling and agility and so on and so on. Another point is about developer workspace. So we see, a lot of developers, even before building and testing, they have to write the code and do some, unit testing or basic testing of their code to make sure that what they push inside, the code repository is something that is, at least past the validation or something like that. So we see also that step of the way in means of giving the developer, it can be a copy, it could be a clone, it can be a remote access to a database, for example, to write his own code and validate his code, and then go on with his business and write the next piece of code or whatever. So there's a lot of agility that we need, data as part of that pipeline. It's not necessarily the pipeline, but the entire, DevOps kind of arena, let's call it. Also, integration testing and, staging and release candidates between different stages of the environment, of the pipeline, sorry. And also a very important piece of it is also bringing back data from production. That could be, for example, a database in your production environment, and using that as a data set for your, a test data set for your, testing or unit testing or QA environments. Instead of waiting hours or using like synthetic workloads, you can use, Kubernetes powered data to actually provide that in a very fast and agile manner to all your developers or throughout your pipeline steps. That's a lot of words. I'm gonna show you that in the demo that I have lined up in the next couple of slides, but we touched briefly about, where data plays part in this kind of environment. And actually, we see that in a traditional DevOps environment, storage and databases are, let's say, decoupled from the pipeline itself. So it's either a completely different pipeline that manages versioning and cloning and creating, or different set of components that are creating those databases for the CI/CD pipeline, or it's just a completely different IT resource or a silo. For example, if you have to have like a DevOps team open tickets with your storage team, you're not very DevOps or cloud native oriented. That's why we believe we need to get back into putting data on top of Kubernetes.
One thing really quickly, Barak, we got a question from the audience. So with respect to your experience, could you please give some advice about which CI/CD tools are good to learn in order to advance as a DevOps engineer? I work with Jenkins, but I don't know Groovy, and I'm struggling to learn.
Okay, so I think the world is pretty much, let's say, divided. I can do a different talk about what
I'm sure.
CI/CD, tools are out there, but in general, a lot of customers, I think it was also reported in the latest CNCF report, I think it was 2020 or 2021, that I think it was like 80 or close to 80% of customers' environments or CI environments are focused on Jenkins, and this is because of legacy, heavy lifting. A lot of code was written on Jenkins, and so it reminds me of the old world, let's call it. But it's very easy. It's open source. Scripting is a bit a hassle there. There's a lot of plugins. Some of them are deprecated. Some of them are not updated at the good period of time. So it's not very solid. But there are like companies that have commercialized that and made that a little bit more easy to consume, let's say. But we see, a lot of like cloud native solutions that are born in the cloud, let's say, that are more oriented towards Kubernetes as the platform for the CI/CD, and these tools like Tecton or Circle CI. We see also Tecton, Circle CI, Algo CD, Spinnaker a bit, and there's a different. I think these are the top names, I think, here and there. But there is a section in the CNCF report about the top install-based kind of for those tools. So you can read about that there, but those are the top ones. All of them are, oriented throughout the same concept and the same, let's call it like metaphors of steps and stages, and doing like operations as code and pipeline as code. All of them are aligned to that. Of course, I didn't mention GitOps as part of it. A part of the big names that are players in this environment, but all of them have the same concepts of running things in steps. But the idea is that, or let's say the purpose of this talk is, I haven't found at least a solution that takes data as a first-class citizen of those pipelines, and we see that throughout all of the flavors of tools that I mentioned, and we see the value of introducing, so Kubernetes has been the platform for a lot of innovation, a lot of new concepts and paradigm shifts that we see in security, in monitoring, in observability, logs, whatever. There's a lot of players there, but data has a little bit stepped behind the other arenas or the other providers in that space. So we believe that data should be as part of your Kubernetes environment. It needs to be consumed by Kubernetes. It needs to be a resource within Kubernetes, and you should operate that the same way you operate your pods, your firewalls, whatever, your Istio deployments. Should be able to do the same operations with a DevOps state of mind, also for your data. And I'll talk about it a little bit later.
Perfect.
Is it good enough? I tried to.
Oh no, definitely. No, I think it's a great answer,
yeah.
And also because I understand and I respect that you talking about different options, because it can become a very thorny issue. Like I always give this example that in a company that I worked at several years ago, the battle between engineers regarding whether or not we should be using TeamCity or Jenkins got so ugly that some people nearly quit the company. So I say people can get very passionate about their tools, but I think it's a nice overview. So thank you.
Yeah, I think that it's very the entire Kubernetes space is very emotional. Let's say a lot of people really like some things. There's a lot of variety for solutions, and I think it's a good thing, because I think the best will prevail and that will survive and be the de facto, let's say, standard as we go forward. But I think there's a lot of innovation coming. So that's why I think this ecosystem is very important. So the more the merrier from my side.
Mm-hmm.
Okay, so this is all the things that we talked about. Scaling your CI/CD solution. Incremental builds is something that we see with some customers that you have to sometimes step back and roll back to a specific point in time in your pipeline that something has crashed or something has errored and you cannot go forward. And instead of completely rebuilding the entire 100 microservices that you have in the environment, you can you can rebuild, or you can, let's say, circle back to a specific point in time and use that as a baseline for your next iterative build in your environment. And of course, as we see Kubernetes as the platform for everything right now, if we looked about 5 years or a bit around that time, Kubernetes was mostly around DevOps or dev test environment, but we see that fully in production now, and we see customers running 3 or 4 different environments for different roles or different operations in their environment. So they need QA and dev test and unit testing, and I have a slide on that as well. So this segmentation of environment is also very limiting when you're running your pipeline, because you have to move data also between those clusters, and it's very limiting with the basic features that you have from Kubernetes. So there's no data agility as part of Kubernetes today, although features are coming more and more, but today that's not the situation. And as I said, we believe that Kubernetes data should be operated together. It should not be siloed as external appliance or an external service that you're consuming. It's part of your infrastructure, and this should be you should be easily provisioning data like a developer and not as a storage admin, let's call it. And those are the top things. So as I mentioned, this is our belief that that we need a container or a Kubernetes storage platform to be part of all of these environments in the DevOps pipeline, right? Okay, so that's the high level intro of it. I want to briefly touch about what is Ionir, where we play part in this kind of environment. So I did a quick intro before, but in essence, Ionir, we are a Kubernetes native software-defined data services platform, and we have a lot of unique, data management capabilities. A part of being completely microservice pods running on top of Kubernetes. Everything is driven by APIs. Whatever you want to do in the system, you can do it automatically with scripts or with API calls. But we're also an enterprise class storage. That means we do have global inline deduplication. We have instant clones, we have instant restore, and we have continuous data protection as part of it. And also we have automated tiering as part of our solution as well. And what are these, very unique solutions? So I picked like 2 that are the most important, or the pieces that I talked about this talk is we can move any volume, or we can move any persistent data in the Kubernetes space between space and between time. What it means that we can move any persistent volume between any Kubernetes cluster, let's say from New York to Dublin, within 40 seconds, no matter what's the distance and no matter what's the size of that persistent volume, we can move it under 40 seconds. And I'll show you a quick implementation of that, how it looks like in a DevOps pipeline in a second. And the second capability that is very important in our production, in our solution, is the ability to move any persistent volume or any data across time. So we have a 1 second granularity, let's call it metadata of any volume in a 1 second space. And you can roll back and clone and create volumes to any point in time that you would like, 1 second granularity. And why that's important? Because if you're running a pipeline that takes an hour or takes 4 hours or even a day, you need that pinpointing and you need that way of specifying to which specific point in time you want to go back to and reshuffle your pipeline stages and scripts and whatever. These are the two ones, and I really want to jump quickly to the demos because I'm trying to be true to time a bit. So I've lined up two important demos. You know what? Before the demos, any questions about what I touched or mentioned here?
No, everything. So yeah.
Perfect. So one more image before the demo, so we have time for that. So this is how we see, a typical DevOps pipeline. You might have the same steps, you might have different steps, you might have, a different combination or flow. But this is, for example, the left side of the slide is what we got from a specific CI tool provider. We gave that as what their customers are experiencing in means of moving data between stages that can be databases or whatever data that is part of your pipeline, artifacts, whatever. And we see that it takes hours to move between your environments. And moving between environments could be different Kubernetes clusters. It can be on the same environment or the same cloud provider. It can be different namespaces within the same Kubernetes cluster. It can be, on-prem and cloud as part of your, your entire ecosystem of operations. So you can have Kubernetes. So we have, let's say, for example, a customer that runs his builds or his builds-oriented steps on-prem, but testing he runs on the cloud, and then the heavy lifting of moving the entire data to the cloud is something that's very limiting him in means of running forward. And with Ionir, we talked about it. Everything is a 40 seconds away, or even 1 second away. So if it's within the Kubernetes cluster, it's 1 second. If it's between Kubernetes clusters, again, no matter what size or distance, it's 40 seconds. So we are bridging that gap in a very solid way. So for the demos, I prepared two demos. One of it is around, I try to make a very nice illustration. I'm not that good of a graphic designer, but I try to build that it makes more sense of what you're seeing in about a second. So this demo that we have is we have a Jenkins, which is our CI automation tool for the purpose of this demo, that is actually installed and running on top of Kubernetes itself. And you'll see that in a second. And it runs a basic build and test pipeline that is actually doing a Git pull of a project that can be my demo is just about a few megs, but your Git repo can be a very heavy lifting or very data specific or sensitive operation in a lot of our customers. You have to check out an entire code for your environment, and then we are cloning that for all the pods that are created in an automated way on top of Kubernetes. And of course, all these operations will be a 1 second or even like instantaneous copies at the speed of Kubernetes. And you will see that the storage piece is also operated at the same level or the same concept. So that's the first demo. Maybe I'll switch to that so we don't mix up too much. Okay, so perfect. So this is our Ionir cluster. We have two clusters here. One is my DevOps environment. The second one is at my production environment. This one is for the second demo that I will show you. But for this demo, we're just going to look at the DevOps environment. And we have our Jenkins deployment, like I mentioned. And there's a few already volumes pre-provisioned here for our consumption. So the demo, what it does is actually, this is our demo. And of course, I need to log in. And this is our demo right now. So the first demo is about parallel build and test. And this what actually it will do is, as I mentioned, it will download and do a checkout of a Git repo that is just as a dummy repo for now. And we'll create clones and we'll create pods to run build and test scenarios that are pre-configured in those jobs. So you can see I have 3 jobs here, and that's the scale that I chose for this demo. But in essence, you can have 5 or 10 or 20, different downstream jobs that do its own, whatever branch or feature or whatever different part of your code that you want to build and test. And let's quickly just run it. So I have my this is my Kubernetes cluster in the background. You can see I have my my Jenkins pod here in a second, right? And we also have our PVC that are pre-configured. And what I'm going to do now is actually launch this job, and I'll walk you through what it does in essence. This is just parameters to make it more easy to consume and run. Perfect. So the job is running right now. We'll go to the console output, and we'll see what actually happening. So Jenkins talks to the Kubernetes platform. It requests a new pod. You will see this pod gets created pretty quickly. You see it's already started the creation. This pod will just do a git pull for our public repo of a specific project. That'll take a few seconds. And once it's done, you can see the content is already here. And it's created 3 clones. So if I go to my environment, I can see I have 3 clones created from this volume, all instantaneously within the same namespace for this example. And then my downstream jobs are starting to run in the backend. So if I do another get PVC, you will see those PVs and PVCs are already bounded and consumed. And now each downstream job is actually running its own thing, right? So one job can be compiling and testing the backend system. The second job can be the front end, and the third job can be whatever app services that you have in your environment, and they're all doing that in parallel. And as I mentioned before, it's all deduped and it's all compressed in means of of your data footprint, let's call it. So that actually you can scale as much as you want, as much as you have resources. And really enjoy the power of Kubernetes. And of course, that can be on-prem or in the cloud or wherever you want to actually run your test jobs.
Okay, we got a question. How did you bootstrap or create the initial Kubernetes cluster?
So for this example, the Kubernetes cluster is very vanilla. It's a kubeadm cluster. It's 3 nodes. I can show you that. It's 3 nodes that are on top of AWS for that matter. And this is how we, this is where we install Ionir in means of grabbing all the local disk and all the local medias and actually, forming that into a pool of storage or to a software-defined storage and give that to the pods to consume, right? And we can see that the jobs have finished. They're all finished successfully. For example, we can see that test job 3, did some tests, and that's about time that it took it. So you can break it down to whatever, granularity or resolution that you want. You can have, multiple different jobs doing different operations and correlate all in the end. But what's important about this, and specifically in this demo, is that although the pods are away and clean in my Kubernetes cluster, again, is very clean, let's call it, I still have the data if I want to do, incremental test, if I want to go back to this point in time and see, what my artifact looks like, what kind of, data did I have there? I have this already lined up here, ready for me to consume. So I can run a different job that goes in, manipulate the data, and closes that data for later use as well. So because it's all dedupe, we don't care about it. It can live in the system. You're only paying for your deltas that you provision on top of that storage system, for example.
Follow-up question to that. Did you use CloudFormation or Terraform?
No, the entire setup is, so I wanted to make it as vanilla or low level, let's call it, for everybody to understand. There's no magic in the back end. It's all Jenkins. I'm using specifically the Kubernetes plugin that you can configure to connect to a specific, Kubernetes backend cloud. They call it like a cloud node, I think. And you just give it the kubeconfig specifically for your cloud. You few clicks of a button, and you have that line up. I actually have a document for rebuilding this environment that is in the works. It's about to be released, I think, in the next couple of days, hopefully before KubeCon. If you're interested in that, send me an email or through Bart or whatever. I'm happily sharing that to everyone. You can experience that. You can make it better. You can, laugh at the way that I'm writing my code. I'm all open for feedback. So, very happy to collaborate on that if you're interested.
Awesome. Good.
Perfect. And the second demo, I'll roll back quickly to our deck, is the second story that I talked about, bringing production data into your DevOps environment and doing, whatever build and test or whatever, code that you want to run on your real data environment. So you don't have to, so the alternatives of customers doing that is either they're creating like a small data set that is not representing, the real environment, or, they have like synthetic environments or, data pumping specific or a subset of the data to production because to the DevOps pipeline, because it takes too much time, because it takes too much effort and, and resources. They choose to limit the way that they introduce data into their pipelines. So what we want to show here is the same kind of flow, but the only different point here is that we are actually bringing a MongoDB from our production cluster in 40 seconds to our DevOps cluster, and then running different jobs all across or talking to that database. And I'll show you that in a second. Perfect. So let's roll back. So if I go back to my production environment, you can see I have a MongoDB here. And this Mongo, has a PV of about 50 gig. We'll use it much less than that. So if I go, this is my production environment. I'm in the Mongo namespace. And if I want to go quickly to my Mongo pod, just to show you that there is real data in there. Right, so we have an 11 gigabyte database here. It has different, mock-up data about, mortgages in the US. If you're interested, I can run a query, but let's leave it like this for now. And what I'm going to do is, as I mentioned, I'm going to run the job. And this I will actually create what we call a teleport, which is actually, making a persistent volume from cluster A to cluster B available under 40 seconds. And you'll see that in a second. And again, it will create three downstream jobs for, creating the MongoDB for each developer, for example, and giving it a pod with Mongo client, and we'll run a quick query across that database. And you will see that under 40 seconds, you get access to real production data throughout the environment. So let's run it, and I'll do a quick talk over to make sense into what you're seeing. Again, this is parameters to make it more scalable and easy to consume. And I'm building it right now. Again, so if I go to the output, I see that it's all operated from Jenkins. I have a teleporter pod that I created. It's just, for talking to the remote cluster. We see this is our, I chose to do it with curl. We can do it whatever. We have an Ionir CTL tool as well. And what you can see in the background is actually, let's start with the namespaces. So I created the namespace per job. And this is for, if it's for a different developer, if it's a different environment, we want to have some kind of a segregation between the environment. So let's dive into a specific namespace. And you can see that we already have the MongoDB PV here. So we are allowing 40 seconds for our magic things to happen in the background. And after these 40 seconds, you will see the rest of the pipeline goes in means of, of steps and all the, downstream job that we have here. So we have it already running. The downstream jobs are actually creating the MongoDB. Take a second. Let's jump into one to see the operation. Perfect. Just fetching a basic Mongo setup from our GitHub. Perfect. And we have the MongoDB here. And the job that is actually running the query is going to run in a second. Oops, some connection failed. Let's see what the problem is. So this actually demo failed, which is a good thing. Let's see the other ones around. Sorry. All of them failed for some connection issues. I can check it later, but if you don't believe me and you want to see this in real life action, you can see that I'm sorry for that. Let's see it for a second again. Yeah, because my Mongo took too much time to start and then the jobs failed. If I run the job again, you can see that very easily. I'll just run the downstream job. That it actually does the same operation. Now the MongoDB is there. I should have allowed more than 5 seconds for Mongo to really start. I should change my demo to be more, let's say, time allowing. And you can see this is the queries against the MongoDB database from production. So it all happened pretty quickly. I had a hiccup there with the timing. I will change that in my demo. But in essence, you see how I introduced a Mongo workload and run some tests and different operations on that production database. And of course, it's a clone. It's not the real database. Whatever I break here will not impact or change the experience in the production environment.
Solid. We got another question. Can you also explain how to analyze issues in Jenkins? I understand it takes place from the console output. Most of the time, I understand if there are any dependencies missing, I tell my developer to look in, but it's still not the perfect solution.
So there's a lot of hand-holding you need to do for your Jenkins environment. In essence, it really depends on where the error is. There's a lot of places that you can go wrong. It can be your own code. It can be dependencies like you mentioned. It can be external resources that you are dependent on. It could be network. It could be configuration. So it's a very hands-on environment. I'm not aware of a pipeline analyzer or a recommender tool, but I can double check if that's interesting enough to check afterwards.
Alrighty, very good. For everyone just to know, Barak is very accessible in our Slack as well as through LinkedIn, or if you want to get in touch, just contact me. So it's very easy to set up.
That's a good call out, yeah. So yeah, that's about it. What I wanted to share with you. I know it was pretty quick. Hopefully,
no, but very practical. Yeah. And it's also nice. I think it's also nice of you to say as a professional that you realize that there are some things in your own demo that you're going to adjust. I think that's cool too.
Yeah. And we are agile, right? So nothing is set in stone. If you want to see something specifically, I'm happy, to invest some time with you, or you can take my guide and do whatever you want and do a better demo yourself. Yeah. You're all invited to it. I just left the points out on the screen if there's any questions, or this is my closing statement. I think we all here are sharing the same passion and understanding that we need to bring Kubernetes and data closer together and actually operate at the same level. So as you saw, I used only Kubernetes commands and views and whatever. Nothing is a different silo. I didn't have to call anyone to get my volume created or whatever. So those are the the motives that we have in the product as well.
No, but I think it's really nice too, because to be, this is live stream number 93. So we've seen a lot of different things, but something so practical and so direct, and really putting the practitioner, at the center. I think it's very, very nice. And I want to say even refreshing to see that. Sometimes things can get a little bit too theoretical about, well, maybe if this particular thing happened, but like I said, this is really, really hands-on. Just really quickly, as you said, moving data and Kubernetes closer to each other. I'm going to steal that from you, actually. Very often we talk about the challenges of running data on Kubernetes. Would you say that Kubernetes is ready for data? And if so, what do you think could make it even more ready? What are the things that need to happen for these processes to become streamlined, normalized, and commonly accepted?
I think in general, I can, let's say, divide it to three. One, I think the market, the macro level, the market will do its thing. So I've been with VMware from very early days. I think my first cluster was 2005 or something like that I installed, or 6 or something like that. And I saw that transition that is very similar to what Kubernetes is experiencing in the past couple of years. It took almost like 5 or 6 years before people really took VMware as a platform, or virtualization as a platform for databases, for production workloads, for whatnots. And after 5 or 6 years, that was de facto, the platform of choice, right? So you have to really have a very good explanation why you want a physical server rather than a VM. And that enabled a lot of innovation with cloud and services and high-tech companies bringing value for customers and so on and so on. And I see the same transition with Kubernetes as well. Mm-hmm. It started as a nice thing that developers use on top of their maybe Minikube or whatever. And Docker was the platform for making it happen, but there was no real market adoption, let's say the first couple of years or so. And I think it will be even a faster revolution with Kubernetes as well. So I think in a couple of years, you will have to explain, why you want to run your workloads on a VM and not on a pod for that essence, right? So that's the macro of it. Internally within Kubernetes, I think we as a community also need to drive content and best practices. And making people understand that data should be on Kubernetes is not something externally, because again, it's part of your platform. And as we drive things forward, and there's more, collateral and IP and guides and blogs and whatever, putting data on Kubernetes, that will make inertia and make things move forward. So we have a big part of that as well. And of course, the third thing is we need to have a good storage solution that is part of Kubernetes. So there's a different forces in the market right now talking about, using other services, I'll call it like that, for your data environments or your data workloads. But I'm a big believer of unification and bringing it all together and not creating silos, because silos create, bureaucracy, it creates slowness, it creates complexity, it creates, like a spoof expert that only know a specific, lever in a specific product, and you need to have like a more architecture, infrastructure look of things. And we see that with networking. Mm-hmm. It's like synonym with Kubernetes. You have the whole Istio networking, whatever, CNI's environment. You have the same in security. We see a lot of boom around security in Kubernetes. The same for FinOps. There are now companies that know how to build pods, how to, give you a specific, financial lookage at your environment based on a label of a specific Kubernetes workload, for example. So we see a lot of things coming together. This is my kind of, approach to things.
No, but I think it's a really nice one. And having seen the evolution that you saw, like you said, going back, to 2005. Seeing the evolution of VMs and where we're at now, like you said, in 2 years, it won't sound crazy at all to say like, well, of course I'm running my data on Kubernetes. Right now we understand it's early days, which is why we're creating all this content, bringing folks together, trying to get these best practices established. But whether it's this technology or any other, there is this period of time of adoption, of experimentation. But then eventually, like you said, the Kubernetes wave that, Ionir and others are surfing is a very strong one that continues to grow every day. And it gives us confidence to see that folks such as yourself that have been in other environments are seeing this now. And I completely agree with what you're saying about the siloing. Silos, I think, sometimes are a form of job protection. That's another talk for another day. But I think it's healthy that there can be distributed knowledge in organizations to have more stakeholders participating and avoiding those kind of silos, like you said, of very specific specialization in one area at the expense of a lot of others. So I think those are great points. We got some folks that are going to reach out to you in Slack to ask some further questions. So that's very, very nice that we were able to stimulate that kind of interest. If I can get you to stop sharing your screen really quickly.
Sure.
As usual, we have our tradition in the Data on Kubernetes community that every time we have a speaker, we have our artist who's lurking in the shadows. Let me know when you can see my screen. So Angel did this, and normally our live streams are a little bit longer, so he has more time. But this time he was very, very focused, getting the racetrack of CICD pipelines going. But anyway, Barak, this was a very good live stream. I thank you very much for your time. I'm very excited about the questions that we got going. Folks, please take advantage. Jump in Slack right now. If you want to continue the conversation, reach out to Barak. He's very accessible. If not there, on Twitter, on LinkedIn, etc. Definitely check out Ionir. You're going to be hearing and seeing more about them. We're very happy to have them as well in our community as a sponsor. So looking forward to more content with you, Barak, and take care in the meantime.
Perfect. Just a very short call out. We are at KubeCon. Come visit us in our booth if you're interested in meeting myself and the other colleagues from Ionir. You're more invited. I think it's SU35 is our booth. Just come around. We have some nice swags and whatever you need to have your KubeCon experience.
Get those swags. Check it out. If for whatever reason, if you're not sure about the booth, just go online. They'll have everything listed. But definitely stop by. I will be stopping by. So I will see you then.
See you there.
Take it easy.